On July 23, 2017, Hurricane Harvey struck the east coast of the United States, dealing over $125 billion in damages. With wind speeds of over 215 kilometers per hour and an average rainfall rate of 10 inches per day for nearly a week straight, entire neighborhoods were destroyed or flooded by this event. But what's going on inside of a storm system like this? I mean, we're all familiar with the vortex-like shape of the clouds, like we can see on the slide here. But understanding what's happening beneath those outer cloud layers is still an active area of research. And although there isn't usually a whole lot of good news associated with a hurricane, we did have a bit of luck from a research perspective in this case. It's because on August 26, when Harvey was in full swing over Houston, a NASA cloud profiling satellite known as CloudSat flew over the northeastern storm center and returned a vertical radar reflectivity profile of the storm's inner workings. These reflectivity profiles are generated by CloudSat shooting specialized radar waves down from space, piercing the outer cloud layers, and reflecting off the particles within the cloud. And we can see that here in the slide as the gradient of colors within the storm center. Now, these reflectivity profiles are extremely powerful for researchers like myself, as they give us a glimpse at the inner workings of a cloud and tell us about the important structural properties in there. For instance, we get to see things like the precipitation rates at each layer. We also get to see what those precipitation types are, so whether it's raining or snowing in the cloud. Furthermore, we get to know something about what's happening beneath the storm system and how much of that precipitation might be reaching the Earth's surface. Now, my research takes us a little further north than Texas, to the Canadian Arctic, where I'm trying to use these reflectivity profiles to understand snow. Specifically, I'm taking estimates of snowfall and averaging them over long time periods, and then comparing the results with data from a variety of weather stations to validate CloudSat's results and quantify any errors in their estimates. My goal is to then determine if we can enhance the accuracy or robustness of current gridded snow products by adding this CloudSat data as a new comparative perspective. Now, this perspective is quite literally space-age technology, right? It's a satellite shooting radar waves down from space instead of a ground station shooting them up from the Earth's surface. And it gives us a novel perspective on precipitation. So it's my hope that through the validation of this CloudSat data, we'll be able to in turn improve gridded snow products and advance our understanding of Arctic snow, especially between weather stations where it's very difficult to get regular ground snow measurements. I titled my talk Cloud Computing today because I believe it's time for this phrase to become more than just a Silicon Valley buzzword, and instead, a term associated with environmental protection and climate change mitigation by understanding the physical clouds that are floating above us. Thank you.